Morning, everyone, and thank you for being with us for today's event, which will consider how the Reach wireless system by Apollo has revolutionized fire detection. Fire detection expert Warren Moyle will explore the Apollo Reach wireless system, which is EN certified and an innovative hybrid wireless technology designed to overcome the complexities of installations in environments with limited or complex access. During his presentation, Warren will provide us with insights into the inner workings and capabilities of the EN-certified hybrid wireless technology and identify how to effectively survey a site, whilst guiding you through the installation process, sharing valuable tips and best practices to ensure a smooth and efficient setup. Get your questions out for our Q&A session at the end, and without further delay, I would like to invite Warren to take centre stage. Good morning, Warren.
Morning, Wendy. Morning, everyone. Thanks for joining us, and thanks for that introduction. So we'll cover the Reach wireless equipment, which is part of the Apollo addressable system. So if you're not aware, we don't make control panels, but there's a number of control panel manufacturers around the world that make an Apollo compatible fire alarm control panel. And they will accept Apollo's XP95, Discovery or Soteria range of products. And they'll also accept a module that you can attach to the system, which is a Reach interface and allows you to attach wireless Reach devices onto the addressable system. So let's just have a look at some of the products in the range for the Reach product. So we were already supplying a wireless product called Expander, which is now 15 years old. Technology's a bit older. So Reach is our next generation wireless fire system, and it's a hybrid wireless system. So hybrid means that part of the system is wired. So you need an addressable control panel. You need a loop of wiring, not necessarily going very far. It can just go through a few Reach interfaces or one Reach interface if you so wish. And then you can attach wireless Reach devices onto that system. So it provides you with a flexible way to extend the wired Apollo protocol loop. And it's based on proven wireless technology that has been around for a number of years now, and is also subject to intensive in-house laboratory testing too. So this is the range of products you can see on the right-hand side there. So the white boxes in the middle are the parts that have to be wired onto the loop, and the group of devices to the left of that are the Reach detectors, call points, sounders, and interfaces that you can add wirelessly onto the system. Obviously, they're all battery powered. They all take an address on our loop of addressable devices. Apollo addressable devices can go anywhere between 1 and 126 on the addressability on that loop. And each of these wireless devices would take up one of those address positions. Some of the reasons for producing a new wireless system: the company that supply us with Reach products, who are Argus Security, they are part of the Halma Group, the same as Apollo is, which means that we should have much more supply chain control and less disruption to the availability of the product. Also, for any new products, we should have a faster development and time to market. And working intergroup companies means that we should have increased innovation and opportunities should there be a chance of developing new products in the range. So this is the system architecture that you can see. So as I was describing, your fire panel would be your addressable fire panel, any Apollo compatible panel, advanced electronics, Kentech, NSC, AMPAC, CTEC, any of those addressable fire alarm panels, with 2 kilometers of cable and your addressable devices attached. And you can add a reach wireless interface anywhere on that loop. It will take an address to the panel. Initially, it will look like a zone monitor unit, and that will be communicating with wireless reach devices out in the field. That will also take an address on the loop, but they're completely wireless and are battery powered. So our wire-free interface, wire-free link for any combination of up to 32 devices out in the field. A radio range, clear line of sight around about 80 meters. Typically in a building, we're going to be talking maybe 40, 50 meters with doors and walls and everything else in the way, which affect the radio signal. Communication is done using the XP95 digital protocol. So the wireless devices don't do any of the advanced features of Discovery or Soteria, whereby you can change sensitivity modes automatically from the panel, or you can have different sounds in the sounders and the audio-visual equipment. They're basic XP95 devices, just giving you fire or fault conditions. And the sounders just giving you the evacuate or the alert condition. There is built-in multi-angle antennas, which give you very good signal integrity in some quite complex radio environments. So if we had more than one interface on the addressable loop, say you can have up to 10 on a loop. If you had that in a building with 20, 30 wireless devices on each one, that's quite a complex radio environment. So the multi-angle antennas give you a very good signal integrity when all those sort of radio signals are flying about in the building. Product size and styling, all the chassis plastics are in pure white. There's a standard mounting base, not a separate wireless base that we had for Expander. So with Expander, you had a separate base that had the radio electronics and the batteries in. With Reach, all of the batteries and the radio electronics are built into the detector head. So it's just one standard mounting base, which you can use for a standalone detector, or you can take the detector off and pair it with a sounder base or a sounder beacon base, which we'll look at in a sec. We've got lots of radio frequency channels available, so 44 on the Reach compared to 32 we have with Expander. And there's less chance of having any dead spots in the vicinity between the radio units that are out in the field. The batteries, we've got a 3 to 5 year battery lifespan. We're actually using only 2 batteries per device, whereas previously with Expander we used 6. And it's a consistent battery type. So we use a CR123 lithium battery, which we know has got a good 10-year life. In any case, we're being a bit conservative and saying the battery life really will be somewhere in the region of 3 to 5 years. A lot of people change batteries every 4 years or so. In the detector range, we have optical smokes and multi-sensor detectors with optical and heat detectors. With the optical smoke and the multi-sensor, there is a dual optical chamber, which gives us an improved false alarm rejection. Essentially, with 2 optical sensors inside, the device can measure the size of the particle that's going into the sensor, and it can reject anything that looks like dust or steam and accept just smoke, what looks more like a smoke particle. So the dual optical chamber is a good sensor to use in these particular devices. There's 3 sensitivity modes inside, so it comes set as standard in the medium mode, but we can make it more sensitive by going to high sensitivity or less sensitive by going to low. Those are set up inside the reach interface that we add onto the loop when we're in commissioning mode. We've got the same sensor inside the multi-sensor. You can't have heat only or smoke only, or you can't swap between the two. It will be set in one of the 3 sensitivity modes, but also have the heat element, which is an A1R heat detector at the same time. A1R is a 57 degree with a rate of rise element. We have that as standard on the heat detector as well, or you can change the sensitivity to a BS mode. BS is a 75 degree heat detector with no rate of rise. So that one's perfect for kitchens and areas where the temperature might change very quickly. With the audio-visual equipment that goes with the Reach, we've got open area sounders in white or red, or open area sounder VADs in white or red. So a VAD is a visual alarm device, which means that it will strobe with a very bright white light, as well as give 100 decibels output on the sound. So these would be used in open areas, corridors, those sort of places. Whereas if you've got sounders inside a room, a smaller area to cover, then you would use a bass sounder probably. We do a bass sounder on its own that you can either put a detector head on or a cap on top of, or a sounder VAD bass. We do a sounder VAD bass with a white flashing LED or a sounder VAD bass with a red flashing LED. Entirely dependent on the management of the system and the design of the system, which color flashing LED we should use. And as I say, you can put a detector on top of there. They would take a separate address each, so the sounder base would be one address, the detector on top would be another address. Or we can just put a cap on the top if we didn't want to put a detector on there. All the settings for the volume and for the flash rate that's coming out of those is set on the device with DIL switches. Last few devices in the range include interfaces. So there is an input module, which to the panel will look like a switch monitor module. It's purely for monitoring switches and monitoring a set of volt-free contacts. So if the contact changes, we send wirelessly a signal to the addressable fire alarm panel. Or an output module, which has got a relay on board capable of switching 24 volts at 1 amp. So if we should want to close fire doors, shut down machinery, that type of thing wirelessly, then we would use the output module. The input module would be used to monitor things like flow switches, non-standard flame beam detectors, that type of thing. There's a remote indicator module, because in some territories that we supply into, there is a requirement to have a remote indicator outside of, for example, hotel room doors, or locked rooms or void detection. The remote indicator looks like an input-output unit to the control panel. So we can set up using the cause and effect in the panel, such that if the detector in the void or the locked room goes into alarm, then the effect of that is that LED lighting up coming on. And the final product in the range is the manual core point. So that's the product range. The brain of the system, if you like, is our loop interface, which sits on the XP95 loop. It doesn't require any external power. It's got an integrated LCD display inside and buttons for commissioning and setup and the status readouts of the system. It's a very small physical footprint with knockouts on most sides for flexibility in location and wiring. There is a short circuit isolator built into that product, which means that the integrity of the loop is still taken into account, such that if we get a wiring fault on our loop, then the isolator will kick in and we won't lose all of our devices that are on the system. And we can have a maximum of 10 of these on a loop. There's 22 available radio frequency pairs that we can use. So if we have several interfaces, each one would use a different radio frequency pair. And we also have survey kit. So it's very important with wireless systems that a site survey is carried out to make sure that the building is capable of using wireless kit. Some buildings will be much different to others. If there's a lot of metal work in a building, then that may affect the radio signals that are produced and go around the building. So the survey kit is very, very simple to use. It has a full frequency scan feature, which allows you to work out which frequencies we're going to use for each area. A selectable channel pair scan option, and then it's just a simple green or red LED pass fail report looking at a detector with flashing LEDs. And these can be all battery powered, or you can use a mains option with the interface unit. So that's what's inside the survey kit. There's your survey interface module, which is the same size and has the same navigation buttons as our hub unit, our interface unit that goes on the loop. We have a survey detector and pole attachment, and that will be used to determine the locations where the product can be installed. It has a bicolor LED which will flash to indicate the signal strength. So that's the big orange detector in the bottom left-hand corner. And there's some batteries provided, lithium-ion batteries, 2 for the detector, 4 for the interface module. And there's also an AC adapter for powering the interface. So to prepare for the survey kit's first use, you remove the front cover, insert 4 batteries, flick the power switch on the top, and it will show the Reach logo on the screen. You just press the enter button, which is in the red ring there, to continue. You're presented with the survey kit's main menu. At the top of the screen, you've got survey. That's used for the point-to-point survey. The scan, the background scan, which is the thing that you perform first before the point-to-point survey. And that will let you know which RF channels are the most congested or noisy so that you can avoid them. There's also a settings option, which is used to pair or unpair the mock detector device, but you won't need to use that initially. So the first thing to do is the background RF scan. So you select scan. The scan will take 4 minutes to complete. It will check each radio frequency channel, and it will tell you the best channels to use after that 4 minutes is complete. So the results will show in order of preference. You can record this data on a survey sheet from the hub, and you will repeat that at every hub location to get the best results. These are the Reach radio frequency channel numbers. So you can see there's a channel pair 1 to 22, and then up to 54 on the other side. We use an 868 megahertz, which is the European frequency for radio systems in Europe. Once we've done our scan, we can select the survey to do the point-to-point survey. We would edit the channels so that we can select the channels that we got on the scan. We can return to the survey menu and we would press Start Survey, turn on the survey device. Once it's powered up, we select Done. And then you're ready to survey. We start getting survey results on the screen. The survey detector LED readouts will indicate the suitability for a product to be installed in the location being tested. So a positive result will be a green LED quick flash. A negative result would be a red LED long flash. And those results are followed by a 1 second blank. And the exception of that is an extremely bad result to indicate the limit of the range. Once we've exceeded that, the LEDs will no longer flash until we come back into range. So it's very, very simple. A one-person survey can be done by putting that mock detector onto the poles that are provided so that you can put the detector up to the ceiling and test each location where you intend to put a detector, or on the wall if it's an interface or a call point or something. If we see green flashing lights, we're happy. If we see red flashing lights, then we wouldn't accept that position and we'd have to move something. So either the detector would have to move or we'd have to find a new location for our interface. This is just to give you an example of the signal quality. So it's indicated with either a green or red flashing LEDs on the survey detector, and we're only going to accept the green flashing LEDs as okay to install. So as you can see there, the results, anything between 0 and minus 80 dBs is a good result, sufficient for fitting a detector or a device. Any red flashing, we're not going to accept. Once we've completed our survey, we should have a full sheet of results recorded in our Reach survey sheet. That's suitable for digital or printed use. So it can be downloaded from our website on the product landing page. And it's important to keep these results for the site installation, as you'll need the RF channels, the hub and the device locations during the setup. Once you've finished a survey, just remember to switch everything off because you'll use up the power in your survey devices very quickly otherwise. But try and do surveys at the busiest time of the day. It's not always possible, as we know, but when most people are in the building, most computers are on, most televisions are on, most footfall is in the building, doors closed between the survey and the surveying device. Try and make it as worst case as you possibly can. But there's always quite a big gap between what we're surveying and the actual kit anyway. So the survey is purely to make sure the building is suitable for wireless equipment in the first instance. Once we put the wireless equipment in there, we've got a much higher signal that we can use to communicate with the devices. So once we have decided where we're putting our interfaces, we'll install the hub. It acts as the translation layer between the Apollo wired loop and the Reach wireless system. Included in the box is a loop interface module, 4 screws, and a quick start guide. As you can see there, just redo that animation. That's the hub as it looks with the front on. You take the front off. Probably have to take the PCB out to get the screws of the box in. Screw it to the wall. It'll probably be quite high up the wall, not right up to the ceiling because there may be metal objects in the ceiling that will affect our signals. So probably about 400 mil down from the ceiling, but as high up as we possibly can so that we can get good wireless communication. Sometimes it's unavoidable that you have to put these things into ceiling voids or into riser cupboards, that type of thing, but just try and leave it in as much free space as you possibly can. When we power up the interface, the first time set up, we'll get to be able to set the date and time. We'll get to select the channel pair, which is selected from our survey result that we've done. You would then get the system ID up, which you don't have to do anything to. It's a factory set ID, and it's different for each interface that we use, so that the devices, when they're logged on, they know which interface that they'll be communicating with. And the hub loop address. So we can set this, it will be default as number 1, but we can change it again if we go into hub settings. But it'll be default set as 1. But if we don't have address 1 available, maybe we've got address 50, we can set it at number 50. We can set it to any loop address between 1 and 126. But just remember, as we add devices on, they will take a subsequent address from that. So if we leave it at address 1, the first device we add is going to be address 2. The next device we add is going to be address 3. But all these things can be changed within the settings. So adding devices is very, very simple. So from the configuration menu, you would select device menu. You would select add device. You would insert the batteries into the wireless device and toggle the switch to number 1. So there's an on and a 1 on the switch. So you switch it from on to 1 and you leave it there. You don't turn it off again once you've paired the device. Once it's successfully paired, it will show the device type and the loop address. And at that point, you can change the loop address if you so require. To add more devices, you just select next. Or to end, you just select exit. If you choose to modify a device later, you want to change the sensitivity or the address or anything like that, then you just go into modify device in the configuration menu, select enter, and then the options include changing the loop address, changing the detector settings. You can look at the alarm status. You can check the device signal quality. All the AV options are done on dip switches on the devices rather than in the interface. So this is only for detectors, interfaces, and call points. If you want to remove a device from the configuration menu, you select device menu, remove the device, select the device number that you want to remove, and then remove the device batteries, select done, and the device will be removed from the system. Very important to do. Don't just take devices off of the site, go away, and then come back again, because it can cause confusion on the system. Once you've finished with your configuration, you can select exit. You will have to confirm that you wish to exit, just to make sure in case you do it by accident. And display now shows the main menu. It will show the system status and the config mode. Now all your devices that you've added onto the interface would be presented to the addressable system at that point. So after that, after you've configured the loop interface, you can then do an auto learn on your panel and pick up those wireless devices. You can look at the system status, which are read-only options, or if you've made a mistake, you can go back into config mode, or if you want to add another device, for example, go back into config mode, which requires a password. The password is 0002 on all of these reach boxes. I'll now hand you back over to Wendy for our Q&A session.
Thank you very much, Warren. That was a comprehensively and informative presentation, which has inspired several questions from our delegates.
Good, good.
But before we go to those questions, I would like to ask you one about standards and how EN certification relates to the Reach wireless system's reliability and performance.
Okay, so prior to that, so the standard for wireless systems is EM54 Part 25. So prior to that being produced, which was in about the mid 2000s, there were wireless systems around, but they weren't to any particular standard, which meant they weren't always reliable. And we had issues with devices dropping out, devices not being seen by the main fire alarm panel, that type of situation, which obviously with a life safety system is critical, really, that all the devices should be there. And if there's a problem, they should be reported to the main panel. So this is what EM54 Part 25 brought us. It made wireless life safety systems as good as a wired safety system and as reliable as a wired safety system, life safety system, which is obviously critical because life and property is precious and we don't want to lose it in a fire. So that's really what the standard was all about.
And very important that we can all work to a standard and, as you say, ensure that life and property is properly protected rather than randomly protected.
Yeah,
Thank you.
absolutely.
Now, Mona Kara and Ali Arif both asked questions relating to Reach's hybrid wireless technology. How does it work? What are the benefits? And what is the split between physical and wireless in hybrid wireless? Can you
Um,
explain further?
there isn't any split particularly. You could have an addressable panel with one interface on a loop between the panel and the interface, and then have up to 32 wireless devices attached to that. Or you could have already an existing system where you've got 50 devices on the loop wired, but suddenly something happens in the building. So a bit UK centric, but possibly filters out over the world a little bit. But if the system is required to be upgraded, for example, so there's some detection required in a certain area or some sounders, in addition to what's already there, and the building is already decorated, rather than pulling up carpets and making holes in nice decorative walls, we can quite easily fit wireless devices onto that system. So there's no particular split between the two. You can have as many wireless devices as you want within the 1 to 126 addresses, or you can have lots of wired devices and a few wireless. It works either way, to be honest, which is really the beauty of a hybrid system.
So somebody has asked about cybersecurity. Does the wireless system also comply with any cybersecurity standards?
There shouldn't be any security issues. The wireless signals are binary signals, ones and zeros. There really isn't any way of accessing the Apollo protocol on an addressable system, which is what is used between the interface and the panel. The wireless signal between the detectors and the interface is done by our supplier, and it's their own protocol that they use, which is all protected and quite secure.
Okay, so the second question, I am very untechnical on these things, but the second question almost, I think the same line is the data digitally signed with a 1 to 8-bit key, and is it encrypted?
It will all be encrypted, yes, and yes, it's a binary algorithm, ones and zeros, digital. Yeah.
Okay, brilliant. Thank you. Now, is there anything you would like to add following your great presentation regarding the technical specification and capabilities of REACH, how they contribute to its effectiveness in fire detection?
Okay, so yeah, so the detectors have, as I was talking about the products themselves earlier, dual optical, which is relatively new technology for discerning between false phenomena and smoke. So therefore, we cut down on problems with false activations caused by things like dust and contamination, and also insects, and also things like steam from bathrooms, that type of phenomenon. So yeah, so there is a lot of technology built into the products to deal with that. Also, modern technology moving along has developed features like drift compensation. So there is electronic compensation built into detectors to compensate for build-up of dust and contamination. So again, trying to cut down on the false alarm sort of problems that have occurred over the years, especially with optical smoke detectors.
And from that point of view, you must be very proud of the fact that REACH will be suitable for almost any application. Is there any application that REACH is now answering a problem that other systems haven't in the past?
Well, with the technology that's built into the devices for false alarm rejection, you could probably use them in the more difficult environments for smoke detectors, which has always been areas like accommodation areas where you've got people living, um, and things like washing facilities in there, cooking facilities, um, sort
Yeah.
of the problems with in large buildings where um, building work and decorating occur and the detectors don't get covered up. They will be much more less prone to false activations because of those things going on.
And false, as you've said all the way along, false alarms are a major problem for building operators, fire and rescue services, and anything that reduces that is
Yeah,
essential, isn't it, for
absolutely.
everyday operation of any type of building, especially business and business continuity.
Yeah, absolutely.
Um, Jonathan Woodley has asked whether there are any specialized tools or equipment that we should be aware of when conducting site surveys.
Only the site survey equipment that we provide. So, and as I think hopefully it showed in the presentation, it's quite a simple survey to do. There is a video on YouTube as well, which shows the surveying, and also the installation commissioning of the products. So just search Apollo fire detectors and REACH, and you'll find those videos on YouTube. Um, but yeah, very, very simple surveying. So the kit that we provide gives you an interface box that you would place in the area where you're going to put your REACH interface, and then it's a simple case of carrying your mock detector around the building and positioning it in the areas where you're going to put detectors and call points and everything else, to make sure you get these green flashing lights. Very, very simple. Red, no go. Green, yep, that's a good spot. Um, so hopefully we've made it as simple as we possibly can, for people to be able to survey, and also for installing the equipment in the first place. There's no, other than what we produce and supply with the REACH kit, there is nothing else that you require.
And how much more training or expertise is required from the individual to become proficient in installing and maintaining the Reach wireless system? Is the YouTube and your CPD hours enough? Is there more that they need to do?
No, you don't really need to do more than that. I would probably say it's always good to get hold of some kit. Maybe do a small installation to start with, if that's possible. Maybe your own office or something like that as a practice. It's always nice to get the kit in your hand and actually work with it, to see how simple it is, but it is really, really easy to use.
Okay, that's good to know. um, so everybody's sort of asking the same question, I think, because it's new, it's a new system. Everybody's concerned about what are the challenges. And you've been very comprehensive in your presentation and in your answers to the questions. But what are the challenges when installing the system, addressing installations in limited or complex access, confined entry, that sort of thing? Are there more challenges for this system than any other?
I don't think there's any more challenges there than any other, really. I think they're probably the most challenging environments for wireless kit that we've encountered so far has been systems going into accommodation areas, because you have to have probably a specific time that you go into these places. The people in the accommodation need to be forewarned that there's going to be engineers around. However, those engineers will be there for should be a very short time. You could actually set this system up in the office and then take it to site, which would even cut down even more time for installing. So you set the system up, you put it in a box, take it to site, put in your interfaces. Hopefully the forewarned tenants of the building allow you access for 5-10 minutes to screw a detector to the ceiling, out again. So what you haven't got there is time taken up with cabling into each of those areas, which would feasibly take much more time than simply screwing a wireless detector to the ceiling. So on that side of things, there's vastly improved installation time, I would say, when you compare wired systems to, wireless or even sort of part wireless systems.
So in commercial and industrial situations, far less downtime where business is concerned.
Absolutely, yeah, and no cordoning off areas, so no loss of business continuity, because you've got engineers putting in wireless detectors.
And do you produce a, how can I put it? Do you produce a living with the reach system where it's being put into residential buildings so that the tenants or the owners have a layman's understanding?
Um, Sorry, can you repeat that question, Wendy?
Yes, of course. What I was wondering is, do you produce a living with a reach system for tenants? I'm talking about residential areas more than commercial. So
Yeah,
the
sure.
residential tenants and owners of the buildings.
It probably not something that we would do. Um, Obviously, because we're the manufacturers, if you like, so we're kind of several stages back from where the detector will end up. So it's usually that type of thing would be more with our customers than with us.
Right.
Um, but
So you don't produce any recommendations for them to
we
do that?
No, we wouldn't do. Although we've certainly been asked to give advice in the past, because you do occasionally get a tenant, somebody who doesn't really understand, asking the question. This is a a wireless device? Is it going to affect me? Is it going to affect my internet, my mobile, that type of
Mm,
thing? So we can
mm,
explain that these detectors use a very small radio signal. And I mean, if you can Google it, it's something like 10 milliwatts of power, which is a minute amount of signaling, um, which really won't affect, things like your internet, or it's not going to give someone an illness or anything like that. It's a minute amount of radio power that we use because we're trying to conserve battery power as well, because we want the device to last, several years, certainly up to 10 years, which is our recommended working life for wired devices. So uh, that's kind of our aim as well, to produce something that's very, very simple, that doesn't take a lot of power, and that doesn't affect other systems and devices that are around the areas where we're likely to put these devices.
right. Warren, I think that you have covered the subject inspirationally, and I hope that all of our delegates have enjoyed this morning's presentation. Any further questions, please send through to us, and we will send them through to Warren. And as he has said, there are things on YouTube you can catch up with on the Apollo Fire YouTube site. Warren, before we go, is there anything you just want to sum up generally? Um, then please add anything to what was already a great presentation.
Um, yeah, so this is our sort of our tagline on our all of our presentations. So this is what Apollo is about when we're designing, developing any sort of detection device. We're always thinking about, this is going to save somebody's life. This is going to protect somebody's property. That is the bottom line of everything that we do. So, and it's all part of our principles at Apollo. So keeping people safe from fire always is our tagline, essentially, and that's hopefully what we aim to do with everything that we do, all the wired devices that we make, and obviously now the wireless products that we're producing and supplying. So hopefully that's a good way to end the morning.
I think it's a very good way because, from my point of view and the team's point of view on Fire Middle East, we hope that our input into the wider world of fire protection is informing people on how to keep safe from fire always.
Yeah,
So,
100%.
thank you very much, Warren and Apollo Fire. And thank you very much, everyone, for listening to us today. Thank you and goodbye.
Thanks everyone.